If you are listening on Spotify right now, please take 10 seconds and leave a review. It costs you nothing, and it means more to this channel than you might realise. 10 seconds of your time keeps this work going, and a very special thank you to Nuked for suggesting this topic. You reached out, and here we are. This one is for you. Before you fall asleep tonight, consider this. Somewhere above you, at this very moment, the planet you live on is wrapped in an invisible shield. You cannot see it. You cannot feel it. You have never once thought about it during the course of an ordinary day. But without it, life on Earth would have been stripped away by the solar wind billions of years ago. The magnetosphere, that vast electromagnetic cocoon extending tens of thousands of miles into space, is the reason you exist. And in the summer of 1962, the United States government detonated a 1.4 megaton nuclear warhead inside it. What they discovered in the aftermath was classified for years. Some of it still has not been fully explained, and a handful of scientists who were there quietly suggested, in documents that were not meant to be read by the public, that the explosion had not simply torn through empty space. It had hit something with structure, something that behaved less like a void and more like a wall. This is the story of Operation Fishbowl, of Starfish Prime, of the strange and luminous anomalies that bloomed across the Pacific sky on a July night that the official record describes as a weapons test and nothing more. And of the theory, persistent and stubborn and impossible to fully dismiss, that when humanity first reached into the upper boundary of its orbital environment with the most violent tool ever created, it did not find emptiness waiting there. It found resistance. Act 1. The Cold War Experiment 1962. The space race intensifies. To understand what happened above Johnston Atoll in the summer of 1962, you need to understand the particular quality of fear that defined that era. It was not the vague ambient anxiety of a world aware of its own fragility. It was something sharper, more specific. The Soviet Union had launched Sputnik in October of 1957, and that beeping silver sphere had cracked something open in the American psyche that 5 years of frantic effort had not yet fully repaired. The sky above was no longer a neutral canvas, it was contested territory, and the rules governing that territory were being written in real time by men who were terrified of losing. The year 1962 was the apex of this terror. The Berlin Wall had gone up the previous summer. Cuba was a powder keg. John Kennedy had been in office for barely a year, and the weight of the nuclear standoff pressed down on every decision made inside the walls of the Department of Defense. In that climate, the question of what a nuclear weapon could do in space was not an academic one. It was urgent. It was operational. It was the kind of question that consumed entire divisions of the most brilliant scientists in the country, funded by budgets that did not appear on any public ledger. The program that emerged from this urgency was called Operation Fishbowl. It was a series of high-altitude nuclear tests conducted under the broader umbrella of Operation Dominic, which itself was one of the largest American nuclear testing campaigns in history. Fishbowl was the space component. The idea was deceptively simple. Detonate nuclear warheads at altitudes ranging from tens of miles to several hundred miles above Earth's surface. Measure the electromagnetic effects. Study how radiation behaved outside the protective envelope of the lower atmosphere. Learn what a Soviet nuclear weapon exploded in orbit might do to American satellites, to military communication systems, to the carefully constructed infrastructure of electronic warfare that the United States was rapidly building into the architecture of its strategic defence. The tests were to be conducted from Johnston Atoll, a remote coral island roughly 820 miles southwest of Honolulu in the central Pacific Ocean. The location was chosen partly for its isolation, partly for its existing military infrastructure, and partly because the direction of the rocket trajectories could be arranged to keep the worst of any electromagnetic effects away from populated areas. Or so the planners hoped. As it turned out, their calculations about what was possible were significantly more conservative than what the test actually produced. The team assembled for Fishbowl represented some of the most sophisticated scientific talent in the Western world. Physicists who had worked on the Manhattan Project, Atmospheric scientists who had spent years mapping the behaviour of charged particles in Earth's upper reaches. Engineers who had designed the earliest American missile systems. They arrived at Johnston Atoll with instruments of extraordinary precision and a genuine expectation that the data they gathered would reshape the understanding of nuclear strategy for the coming decade. What they did not expect was that some of the data would reshape something else entirely, something harder to name, something that several of them spent the rest of their careers trying to quantify. The first two tests in the Fishbowl series, conducted in late May and early June of 1962, were failures. The rockets malfunctioned. One had to be destroyed by the range safety officer when it began veering off course. The debris fell into the Pacific and contaminated portions of Johnston Atoll with radioactive material that would require cleanup operations for years afterward. The pressure on the program was immense. 1962 was not a year when the United States government had tolerance for expensive failures, particularly ones that scattered plutonium across a military installation in the middle of the Pacific Ocean. The engineers worked around the clock. The scientists rechecked every calculation, and on the 9th of July, 1962, they were ready to try again. AST-1. Continued July 9th, 1962. Starfish Prime. The weapon they were preparing to launch was designated W-49. It sat atop a Thor rocket at the Johnston Atoll launch facility, a cylinder of engineered destruction carrying a yield of 1.4 megatons. To put that number in context, the atomic bomb dropped on Hiroshima had a yield of approximately 15 kilotons. The device sitting on the launch pad at Johnston Atoll was roughly 93 times more powerful. It was not the largest nuclear weapon the United States had ever tested, but it was by a wide margin the largest thing any human civilization had ever attempted to detonate in space. The launch window opened at 11 at night local time. The Thor rocket ignited and climbed. Tracking systems on Johnston Atoll followed its ascent. Observation posts scattered across the Pacific watched the sky. In Hawaii, 860 miles away, civilians had been advised that a test was planned, but had been given no specific details about what to expect. Some had gathered on beaches and rooftops, others were asleep. None of them were fully prepared for what they were about to see. At 13 minutes and 41 seconds after launch, the warhead detonated at an altitude of approximately 250 miles above the Earth's surface. The yield was exactly as designed, and the sky above the Pacific Ocean became something that no human being had ever seen before, and no photograph has ever quite managed to capture. The immediate flash was expected. A nuclear detonation in space produces an intense pulse of X-rays that travels outward from the point of explosion at the speed of light. Those X-rays, encountering the upper atmosphere, generated a secondary radiation field that lit up a vast arc of the sky in a white-green luminescence that witnesses described as blindingly brilliant even from hundreds of miles away. Then the colours changed. Red and blue and purple ripples spread across the night in expanding rings, electromagnetic ribbons that covered an area of sky so enormous that observers in New Zealand, more than 4,000 miles from the detonation point, reported seeing unusual aurora-like colours above the horizon. The electromagnetic pulse from Starfish Prime was the largest ever recorded from a nuclear test. It disrupted radio communications across the Pacific for roughly 30 minutes. In Hawaii, the electromagnetic surge knocked out streetlights across the island of Oahu. Burglar alarms triggered without cause. Circuit breakers failed. The power disruptions affected areas far beyond what the theoretical models had predicted. 300 telephone circuits in Honolulu went dark. The microwave links connecting Hawaii to the mainland became temporarily unusable. But these effects, dramatic as they were things the scientists could explain. Electromagnetic pulses were a known phenomenon. The scale was surprising, but the mechanism was understood. What was not so easily explained were the observations that came in over the following hours and days, and the patterns that emerged in the data as analysts worked through the readings from the instruments that had been deployed across the Pacific in advance of the test, because something else had happened at 250 miles above the Earth, something the instruments had recorded with clinical precision, and that the theoretical frameworks available in 1962 had only partially equipped anyone to interpret. ACE-2, the strange data, the unexpected radiation belt. In the days following Starfish Prime, as the debris of light and electromagnetism settled, and the data streams from observation platforms across the Pacific were compiled and analysed, a picture began to form that surprised even the most experienced members of the Fishbowl scientific team. The nuclear detonation had done something that the existing models had not predicted with any precision. It had injected an enormous quantity of high-energy electrons into the region of space where Earth's magnetic field concentrates and traps charged particles. And those electrons were not dispersing, they were staying, circling the Earth along magnetic field lines, caught in a kind of orbital loop that had no precedent in the natural record. A new radiation belt had formed around the planet, not a natural one, an artificial one. Built in a single evening by a single explosion, it wrapped around the Earth at altitudes corresponding to the region where the detonation had occurred, and extended in both directions along the magnetic field lines toward the polar regions. The belt was intensely radioactive, and it was persistent. Scientists monitoring it expected it to dissipate within days or weeks as the trapped electrons gradually lost energy and scattered. Instead, it lasted for years. The practical consequences were severe. 7 satellites in orbit at the time of the detonation or shortly afterward were damaged or destroyed by the unexpected radiation environment. Among them were Telstar 1, the first commercial communications satellite, which had been launched just the day after Starfish Prime, and which began suffering electronic failures almost immediately as it passed through the artificial belt. The British satellite Ariel 1 was disabled. The Soviet satellite Cosmos 5 malfunctioned. In total, the Starfish Prime radiation belt is believed to have contributed to the failure of roughly 1/3 of all satellites in orbit at the time. It was an unintended act of warfare against the entire global satellite infrastructure, conducted in the name of studying how to conduct warfare against the entire global satellite infrastructure. The official scientific explanation for all of this was coherent and, within the limits of the knowledge available at the time, convincing. The nuclear explosion had injected energetic particles into the magnetosphere. Earth's magnetic field had trapped them. The Van Allen radiation belts, which had been discovered only 4 years earlier by the Explorer 1 satellite mission, were known to operate through exactly this kind of trapping mechanism. Starfish Prime had simply demonstrated that a human activity could artificially augment and extend that trapping on a scale that had not been appreciated before the test was conducted. Case closed. The data was filed. The satellites were mourned. The strategic implications of the electromagnetic pulse were studied carefully by military planners who took the lessons seriously and quietly began hardening critical military electronics against the kind of pulse that had knocked out the streetlights in Honolulu. Life moved on, but several of the scientists involved in Fishbowl were not quite satisfied. Not with the explanation itself, which was essentially correct as far as it went. With something in the data that the explanation did not quite account for. Something in the telemetry readings from the Thor rocket during the final minutes of its ascent. Something in the records from the observation satellites that had been positioned to monitor the detonation from multiple angles. Something about the way the fireball had expanded that did not match the behaviour the theoretical models predicted, even when those models were extended to account for the magnetic trapping effect. The fireball had not dissipated the way it was supposed to. At a specific altitude range, it had done something different, and the instruments had recorded exactly what that something was, in meticulous and unambiguous detail, before the data was collected by the agencies responsible for analysing it, and portions of it quietly ceased to be available for further review. Act 3. The anomaly, the missing telemetry. Declassified documents from Operation Fishbowl began entering the public record in fragments over the decades following the tests. The process was gradual and uneven, as declassification processes always are. Different agencies released different portions of the records at different times. Some documents were released with portions redacted. Others appeared in archives in ways that suggested their indexing had been deliberately obscured. listed under general headings that did not accurately describe their contents, embedded in larger collections in ways that made individual retrieval difficult, without knowing specifically what to look for. Researchers who worked through these records in the 1980s and 1990s noted something that was difficult to fully explain through simple, administrative chaos. The gaps in the telemetry data were not random. They were not distributed evenly across all altitudes and all phases of the rocket's flight. They clustered, and the altitude range where the clustering was most pronounced was the range between 230 and 260 miles above the Earth's surface, precisely the range where the W-49 warhead had detonated, precisely the range where the fireball had expanded and the electromagnetic pulse had originated, and whatever had happened in those seconds of maximum energy release had been most directly observable by the sensors on the rocket itself. The technical argument for why this might happen innocently was straightforward. The sensors closest to the detonation would naturally produce the readings most affected by the explosion itself. Electromagnetic interference from a 1.4 megaton nuclear detonation is not a subtle effect. It is entirely plausible that instruments measuring conditions at the precise altitude of the explosion would have been saturated by the event they were attempting to measure, rendering those specific readings useless in ways that readings taken from greater distances were not. This explanation was accepted by most researchers who encountered the gaps. It was reasonable. It was technically defensible. It required no conspiracy to explain it. But some of the missing data did not come from instruments positioned at the detonation altitude. Some of it came from observation satellites in higher orbits, monitoring the event from above. Those satellites had no proximity issue. Their sensors were not saturated by being too close to the explosion. They were positioned specifically to provide a clean view of the fireball development from a distance that should have kept their instruments fully functional throughout, and their data for the altitude range between 230 and 260 miles was also incomplete, not destroyed, not corrupted by electromagnetic interference, simply absent from the archives in the portions where those altitudes and those specific observation angles intersected, present in the portions covering higher and lower altitudes, present in the portions covering the same altitude range from different observation angles, that provided less geometrically precise information about what was happening at the boundary where the fireball met whatever it met. This was the detail that stayed with a small number of researchers and refused to be fully explained away. Because there is a difference between data that is lost due to instrument failure and data that is selectively absent in precisely the ways that would be most informative if something unexpected had been observed. The first kind of loss has a random, equipment-determined character. The second kind has a pattern, and patterns, in the analysis of declassified records, are worth paying attention to. Act 3. Continued the atmospheric boundary. The visual record from Starfish Prime is extensive. It was the most heavily documented nuclear test in the history of atmospheric and space testing, for the simple reason that it was the most spectacular. The combined light and electromagnetic phenomena it produced were observable across an area of the Pacific that encompassed hundreds of thousands of square miles, and the military and scientific teams responsible for monitoring it had positioned camera platforms, photometric sensors, and visual observers at dozens of locations across that area. The resulting archive of visual documentation is rich and detailed, and has been studied extensively by atmospheric physicists and historians of science alike. What those documents consistently describe, from observers at multiple locations and from multiple instrumental platforms, is a fireball that behaved in two distinct phases. The first phase was the expected one. The initial detonation produced the characteristic X-ray pulse and the immediate flash, followed by the rapid expansion of the superheated plasma ball. This phase looked more or less as the models predicted, scaled to the exceptional energy release of a 1.4 megaton detonation in a near-vacuum environment. The physics were extreme, but they were recognizable. The second phase was less expected. As the fireball expanded beyond a certain radius, observers described a change in the character of the expansion. The plasma, rather than continuing to dissipate outward in a roughly spherical pattern, began to interact visibly with the surrounding environment in a way that produced an asymmetry. The glow became elongated along the magnetic field lines. It expanded preferentially in directions that corresponded to the lines of force in Earth's magnetosphere rather than simply radiating outward in all directions equally. This was the magnetic trapping effect that the official explanation described accurately. But some observers reported an additional feature, a feature that was described in consistent terms by multiple, independent accounts, and that appears, in the available documentation, to have been observed before the magnetic elongation effect became dominant. A distinct brightness at the outer boundary of the expanding fireball, a zone where the plasma appeared to be interacting with something that offered resistance to its expansion. Several observers used the same word: a wall, a boundary, a surface against which the expanding energy pressed and was deflected. The official scientific interpretation of this observation was that the expanding plasma was interacting with the ambient magnetic field, which at those altitudes has sufficient density and structure to produce visible effects on a plasma of the kind the nuclear detonation had created. This interpretation is correct in its essential mechanism. Earth's magnetic field does have the character of a structured boundary at those altitudes, and a plasma expanding into it would produce exactly the kind of luminous interaction that was observed. What the official interpretation does not fully account for is the scale and geometry of the interaction. The boundary effect observed by Fishbowl monitoring teams was not a gradual dissipation into an increasingly resistant medium. It was, according to the most detailed accounts in the declassified record, a relatively sharp boundary, a zone of interaction narrow enough to produce a visible distinction between inside and outside, something more like a surface than a gradient. And in the decades since those observations were made, the understanding of what that surface is and how it behaves has grown considerably more complex than the 1962 model suggested it should be. AST 4, the conspiracy theory, the barrier hypothesis. Every conspiracy theory has a seed, a place where the officially accepted account and the observed facts leave a gap just large enough for a different kind of story to take root. The conspiracy theory surrounding Operation Fishbowl is unusual in that its seed is not a fabrication or a distortion of the evidence. It is a genuine question that the official record genuinely does not answer in full, and it is the kind of question that, once you have spent any time with the Fishbowl documentation, becomes very difficult to stop thinking about. The question is simple. If the test was purely about measuring the electromagnetic pulse effects of a nuclear detonation in space, and if the data on those effects was fully captured, and is largely available in the declassified record, why are the specific records corresponding to the altitude range of the detonation itself incomplete? What was being measured at that altitude range that was distinct from what was being measured above and below it? And what did those measurements show that merited a handling protocol that resulted in the gaps the researchers found? The conspiracy theory that grew around these questions posits that Operation Fishbowl had a secondary objective that was never stated in the official program documentation. That alongside the strategic mission of studying electromagnetic pulse effects on communications infrastructure, there was a scientific mission of a different kind. One focused not on what nuclear weapons could do to military satellites, but on what the upper boundary of Earth's electromagnetic environment actually was, and how it behaved when subjected to an energy input of extreme magnitude. According to this theory, physicists working on the program had developed theoretical models suggesting that Earth's magnetosphere had structural properties that were more complex than the simple gradient models of the late 1950s implied, that at certain altitude ranges the interaction between the solar wind, Earth's magnetic field, and the ambient plasma environment of near-Earth orbit produced something that functioned almost like a surface. Not a rigid one, not an impenetrable one, but something with more defined boundaries and more interesting physical properties than the textbook description of the magnetosphere as a smoothly varying field suggested. The nuclear tests, in this version of events, were designed to probe that structure. Not because anyone suspected anything extraterrestrial or exotic was responsible for it, but because a 1.4 megaton nuclear detonation was, in 1962, the most powerful tool available for forcing a measurable response from a physical structure at that altitude range. It was the largest hammer humanity had ever built, and the question it was being used to answer was whether, when you swung it at the invisible architecture of the space 250 miles above your head, that architecture swung back. The answer, according to the theory, was yes, it did, in ways that the instruments recorded with precision, in ways that the observational accounts described in consistent detail, and in ways that the relevant portions of the data archive were subsequently managed to prevent from becoming part of the widely accessible scientific record. Act 4 continued the artificial shield theory. In the years following the Fishbowl tests, a body of research emerged that shed increasing light on the nature of Earth's magnetosphere and its interaction with the solar wind. This research was not classified. It was conducted openly, published in scientific journals, discussed at conferences, and built upon by successive generations of atmospheric and space physicists in ways that have produced an increasingly detailed picture of how the electromagnetic environment of near-Earth space actually works. What this research revealed, incrementally, and with the precision that rigorous science brings to complex problems, was that the magnetosphere is not a simple, smoothly varying field. It has regions, it has boundaries, it has zones of sharp transition where the character of the environment changes rapidly over short distances. Some of these boundaries are dynamic, shifting in response to changes in solar activity. Others are more persistent, defined by the underlying geometry of Earth's internal magnetic field in ways that are relatively stable over long timescales. Among the most significant of these boundaries is the plasma pores, a relatively sharp inner boundary of the plasmasphere, the region of cold dense plasma that occupies the inner magnetosphere. The plasma pores is not located at 250 miles above Earth's surface. It is considerably farther out, typically at altitudes of several Earth radii. But the existence of the plasma pores and the physical mechanisms that create it lent scientific legitimacy to the broader idea that Earth's electromagnetic environment contains structures that function as boundaries rather than gradients. What the post-Fishbowl research also revealed was a phenomenon that, to some researchers, seemed almost specifically designed to give the barrier hypothesis new legs. In 2012, a team of researchers working with data from NASA's Van Allen Probe's mission discovered what they described as an impenetrable barrier in the inner Van Allen radiation belt. At an altitude of approximately 11,000 miles above Earth, the inward drift of ultra-relativistic electrons, the highest energy particles in the outer radiation belt, appeared to be blocked by a structure whose existence and mechanism were not immediately obvious from the existing models. The researchers characterized it as a sharp, impenetrable barrier. The electrons, despite having energies in excess of 1 mega-electron volt, could not cross inward of a certain boundary. The barrier held with a rigidity that surprised the researchers and that required several years of follow-up investigation to partially explain. The explanation that eventually emerged involved the interaction between the electrons and very low-frequency radio waves generated by lightning storms in Earth's lower atmosphere, waves that propagate upward into the magnetosphere and create a scattering effect that prevents the highest energy electrons from penetrating beyond a certain point. To the Fishbowl conspiracy theorists, this discovery was not a resolution of the mystery, it was a confirmation of it. Because the discovery of an actual impenetrable barrier in Earth's radiation environment, announced 50 years after Operation Fishbowl by a peer-reviewed NASA research team, seemed to validate exactly the conceptual framework that the barrier hypothesis had been built around. The idea that Earth's electromagnetic environment contained sharp boundaries with specific physical properties was not a conspiracy theory. It was, as of 2012, peer-reviewed science. The question that the conspiracy theory asks is not whether such boundaries exist. They do. The question is whether Operation Fishbowl found one of them, and what exactly it found, and why the specific data that would answer those questions with precision is the data that is missing from the archive. Act 5, the classified results, the satellite failures, the damage Starfish Prime inflicted on the satellite infrastructure of 1962 has been documented extensively and is not seriously disputed by anyone. 7 satellites were directly affected. 3 were destroyed or rendered permanently inoperable within months of the test. 4 others suffered degraded performance that shortened their operational lifespan significantly. Given that the entire in-orbit satellite population at the time consisted of only a few dozen active spacecraft, the loss of 7 represented a catastrophic blow to the nascent space industry and to the military communications networks that depended on those assets. What is sometimes lost in the summary statistics is the specific character of the satellite failures. Not all of the affected satellites were at the same altitude as the detonation. Some were in orbits that should have placed them well outside the most intense region of the artificial radiation belt. Their degradation, while less severe than that of satellites at lower altitudes where the trapped electron densities were highest, was still more rapid than would have been expected based on simple models of how the artificial belt should have spread and diminished over time. The pattern of satellite failures, analysed in retrospect by researchers who had access to the orbital data and the radiation exposure records, suggested that the artificial belt was more spatially complex than the simple, toroidal shape that basic magnetic trapping theory predicted. It had structure, regions of higher and lower intensity that did not correspond straightforwardly to the predictions of the models. Some of this complexity could be attributed to the existing natural radiation belt structure, which the artificial belt was superimposed upon rather than replacing, but some of it could not be easily explained by that superposition alone. Military planners who reviewed the Starfish Prime results took a specific lesson from the satellite failures. The lesson was that a nuclear detonation in space, conducted by a hostile power over American territory, could effectively destroy the satellite infrastructure on which American military communications, early warning systems and strategic reconnaissance depended. This was a serious strategic vulnerability. It demanded attention, and it received attention in classified programs whose full details are still not publicly available, focused on hardening military satellites against radiation and on developing contingency communication systems that would remain functional in a post-nuclear detonation orbital environment. But there was a second lesson embedded in the data that received less explicit attention in the strategic documents that became part of the declassified record. A lesson about the relationship between a high-altitude nuclear detonation and the structures of the orbital environment itself. A lesson about what those structures could absorb and redistribute and what they could not. A lesson that, if fully understood, might have profound implications not just for military planning, but for the basic scientific understanding of what Earth's electromagnetic environment actually was and how it functioned as a system. The strategic documents addressed the first lesson in detail. The second lesson's treatment in the declassified record is, to put it carefully, less comprehensive. Act 5. Continued the Sudden Treaty. In the summer of 1963, 1 year after Operation Fishbowl, the United States, the Soviet Union, and the United Kingdom signed the Partial Nuclear Test Ban Treaty. The treaty prohibited the testing of nuclear weapons in the atmosphere, in outer space, and underwater. Underground testing was permitted to continue, and all 3 nations continued to conduct underground tests for decades afterward. But the environments where the most dramatic, most observable, and most scientifically informative kinds of nuclear experiments could be conducted were now closed off by international agreement. The official explanation for the treaty was the one that appeared in the public statements of the signing governments. Environmental concerns, the contamination of the global atmosphere by radioactive fallout from above-ground testing, had become a serious public health issue, widely documented by scientists and widely protested by civil society. There was genuine popular pressure for the treaty across all 3 nations. The political will to sign it was real, and the environmental rationale was real. The geopolitical dimension was also real. The early 1960s were a period of intense diplomatic activity on nuclear issues following the Cuban Missile Crisis of October 1962, which had brought the world closer to nuclear war than any other event in the Cold War period. The Partial Nuclear Test Ban Treaty was one of several diplomatic initiatives aimed at reducing the temperature of the nuclear confrontation and establishing at least minimal channels of communication and agreement between the superpowers. In that context, it was a significant achievement, and the people who negotiated it understood it as one. None of this is disputed by anyone. The treaty happened for the reasons the historical record documents. The environmental concerns were real. The political will was real. The diplomatic context was real. What the conspiracy theory adds to this account is a supplementary reason. One that does not contradict the official explanation, but sits alongside it as a second motivation that the official explanation does not mention. The theory suggests that among the results of the Fishbowl test was a finding, shared through intelligence channels between the American and Soviet programs, that the detonation of nuclear weapons in near-Earth space created effects on the orbital environment that were more severe and more persistent than either side had anticipated. Not merely the electromagnetic pulse effects and the satellite-damaging radiation belts, which were dramatic enough, but something about the interaction between those detonations and the structural properties of the magnetosphere at the altitude ranges where they occurred. Something that suggested the cumulative effect of continued high-altitude nuclear testing could alter the orbital environment in ways that were not fully predictable and not obviously reversible. In this telling, the Partial Nuclear Test Ban Treaty was not only a response to public pressure and geopolitical opportunity, it was also a precautionary measure taken by governments that had learned something about the fragility of the invisible architecture surrounding their planet, and had decided, for reasons they did not publicise, that continuing to hit it with nuclear weapons was not prudent. This is a theory. It is not documented, but it is not, given what the science now tells us about the structural complexity of the magnetosphere and the persistence of the Starfish Prime radiation belt, an obviously unreasonable one. Act 6. The Final Theory. The 230-mile discovery. Bring all of this together and a picture forms, not a complete one, not a documented one, but a picture with enough internal coherence to explain why it has persisted in the literature of unconventional history for 6 decades, and why it continues to attract the attention of people who approach it with genuine curiosity, rather than reflexive either belief or dismissal. In the spring and summer of 1962, the United States government conducted a series of nuclear detonations in near-Earth space as part of Operation Fishbowl. The stated objectives of those tests were military and strategic. The actual scientific program was more expansive than the public documentation indicated. Among the questions that some of the scientists involved were trying to answer was a question about the nature of Earth's electromagnetic environment at the altitude ranges where the tests were conducted. Specifically, whether that environment had structural properties at those altitudes that the existing models did not fully describe. The tests, and particularly Starfish Prime, produced results that exceeded the expectations of the models in multiple ways. The electromagnetic pulse was larger than predicted. The artificial radiation belt was more persistent than predicted. The visual phenomena were more extensive and more geometrically structured than predicted. And the specific observational data from the altitude range of the detonation contained features that were described by observers in terms suggesting a sharp boundary interaction rather than a gradual gradient interaction. The portions of the data archive that would be most informative about the nature and properties of that boundary interaction are the portions that are incomplete in the declassified record. This incompleteness is concentrated at precisely the altitude range and observation geometries that would provide the most direct evidence about what happened at the outer boundary of the fireball when it met whatever it met at 230 to 260 miles above the Pacific Ocean. Within a year, an international treaty was signed that prohibited further nuclear tests in space. The artificial radiation belt persisted for years, damaging satellite after satellite in ways that demonstrated, beyond any reasonable doubt, that human activity at the altitude range of the Fishbowl tests could produce effects on the orbital environment that lasted far longer and spread far wider than anyone had predicted. And the scientific understanding of Earth's magnetosphere developed over the following half-century toward a picture in which that environment contains sharp structural boundaries with complex physical properties, culminating in the 2012 Van Allen probe's discovery of what the researchers specifically called an impenetrable barrier. Was there a discovery at 230 miles? Was it classified? Was the treaty partly motivated by what the tests revealed about the fragility and the structure of the orbital environment? These questions cannot be answered with certainty from the available evidence. The gaps in the record are real. The anomalies in the data are real. The structural features of the magnetosphere that lend plausibility to the barrier hypothesis are real. What exactly was observed, and what was decided about it, remains, like so much of what happened in the classified science of the early 1960s, partially obscured behind the wall that governments build around the things they decide the public does not need to know. What we can say is this: Operation Fishbowl was not simply what it appeared to be. The most powerful nuclear detonation in the history of space exploration produced results that reached far beyond the electromagnetic pulse and the satellite failures that entered the public record. Some of those results are still waiting in archives that have not yet been fully accessed, in documents that have not yet been fully processed, in the quiet spaces between the things we know and the things we've been told. And somewhere above you, right now, the invisible architecture of Earth's electromagnetic environment continues its work, deflecting the solar wind, channeling the charged particles that would otherwise strip away the atmosphere, holding the fragile bubble of air and water and life against the indifferent pressure of interplanetary space, doing what it has done for 4.5 billion years, since long before any creature on this planet was capable of wondering about it. The question that Operation Fishbowl asked, and perhaps answered, was how strong that architecture really was, whether the boundary it maintained could be stressed, whether the invisible wall at the edge of the breathable world was as solid as the existence of everything living on the planet below it implied it must be. The data that would tell us what they found is mostly gone, but the treaty that followed suggests that whatever they saw at 230 miles in the summer of 1962, they were sufficiently impressed by it to decide that humanity should probably stop hitting it with nuclear weapons. That seems, under the circumstances, like the right call. Asset 6. Continued. What the scientists said when no one was recording. The formal scientific literature from Operation Fishbowl is one kind of document. Precise. Measured. Written in the particular language of people who have been trained to say exactly what they can prove and nothing more. But there is another kind of record that emerged from Fishbowl, less formal, less controlled, and in some ways more revealing. Oral histories, conference presentations, the kinds of remarks that physicists make to one another after the official sessions have ended and the presentations have been put away, and the conversation has moved to dinner tables and hotel lobbies and the long flights home from scientific meetings. In those less formal spaces, a handful of the scientists who had direct involvement with Operation Fishbowl said things that they did not say in print, things that colleagues remembered and sometimes wrote down, and occasionally shared with researchers who were trying to build a more complete picture of what had actually happened during those months above the Pacific. The picture that emerges from these accounts is not dramatic. It is not sensational. It does not involve alien structures or supernatural phenomena or any of the more extravagant constructions that popular conspiracy culture has sometimes grafted onto the Fishbowl story. What it involves is something more interesting than any of those things. It involves scientists who encountered results that did not fit their models, who spent considerable effort trying to fit them anyway, and who eventually settled into a private acknowledgement that the models had not been adequate to describe what the tests had revealed. Not because the physical mechanisms were beyond understanding, but because the complexity of the magnetosphere at the altitude ranges the test had probed was greater than the available theoretical frameworks had captured. One of the consistent themes in these informal accounts is the behaviour of the fireball at the outer boundary of its expansion. The standard model predicted a gradual, roughly spherical dissipation of the plasma as it expanded into the near vacuum of the upper atmosphere and encountered the increasingly sparse particle environment of near-Earth space. What was observed was something that, while consistent with the basic mechanism of magnetic field interaction, showed a degree of spatial definition that the models did not predict. The boundary was sharper than it should have been. The transition from inside to outside was more abrupt. The plasma interacted with its environment at the outer edge in ways that produced a luminous boundary region rather than a smoothly fading gradient. The plasma physicists on the team had a framework for this. Plasma boundaries, under certain conditions of magnetic field geometry and particle density, can develop sharp transition regions through physical mechanisms that were, by 1962, at least partially understood. The magnetopause, the outermost boundary of Earth's magnetosphere where the solar wind pressure balances the magnetic field pressure, is one example of such a boundary. It is a sharp transition, not a gradual one, and its existence had been confirmed by early satellite measurements in the late 1950s, what the informal accounts from Fishbowl scientists suggest is that the sharp boundary observed at 250 miles was not fully explained by the magnetopause analogue, because the magnetopause is roughly 10 Earth radii out from the planet's surface, not 250 miles. At 250 miles, the relevant magnetic structure is something closer to the inner magnetosphere, where the geometry is different and the existing models in 1962 were considerably less developed. The sharpness of the interaction at that altitude range was, in the private judgment of some of the scientists who observed it, more pronounced than the theoretical tools available at the time could satisfactorily account for. This is not a dramatic revelation. It is the kind of thing that happens constantly at the frontiers of empirical science. The world turns out to be more complex than the current models describe. More data is needed. Better models are developed. The anomaly is eventually explained, or it is folded into the growing acknowledgement that complex physical systems routinely produce behaviours that simple models do not predict. This is the normal life of science. What is unusual about the Fishbowl case is not that the models failed, it is that the specific data that would have been most useful for improving those models in the aftermath of the tests is precisely the data that is least available in the declassified record. The informal accounts suggest the scientists knew what they had seen. The formal record suggests that a decision was made about how much of what they saw would be accessible to the broader scientific community. And the question of who made that decision, and what criteria they applied, and what they weighed in the balance when they made it, is a question that the documents that survive do not answer. ACID 6. Final, the legacy of the largest nuclear detonation in space. In the years and decades that followed Operation Fishbowl, the scientific community slowly built a more comprehensive picture of Earth's electromagnetic environment that addressed many of the questions the Fishbowl tests had raised and failed to fully answer. The Van Allen Probes mission, launched in 2012, produced a revolution in the understanding of the radiation belts and their dynamics. The discovery of the impenetrable barrier at 11,000 miles was only one of its findings. The probes also revealed in extraordinary detail how the radiation belts expand and contract in response to geomagnetic storms, how wave-particle interactions shape the distribution of energetic electrons, and how the inner magnetosphere responds to the varying intensity of the solar wind. This body of knowledge has enormous practical significance. The radiation environment of near-Earth space is a critical consideration for every satellite, every crewed spacecraft, every mission to the moon or beyond. Understanding the belts, their boundaries, their dynamics, and their response to disturbances is not an academic exercise. It is an engineering necessity. And the understanding that has been developed over the 60 years since Fishbowl is vastly more sophisticated and more quantitatively precise than anything available to the scientists who watched a 1.4 megaton warhead light up the Pacific sky in 1962. None of this scientific progress has definitively resolved the questions that the conspiracy theory around Operation Fishbowl asks. It has provided context. It has demonstrated that the magnetosphere does indeed contain sharp structural boundaries with complex physical properties. It has confirmed that the interaction between energetic plasma and those boundaries can produce effects that simple models do not capture. It has, in some respects, provided a more sophisticated version of exactly the conceptual framework that the barrier hypothesis was built around. What it has not provided is access to the specific data from July 9th, 1962, that would allow a direct comparison between what was observed at 250 miles that night and what the subsequent decades of research have revealed about the structure of the magnetosphere at those altitudes. That data remains incomplete. The gap remains. and the questions it generates remain unanswered not because they are unanswerable in principle, but because the evidence that would answer them is not fully available. There is a version of this story in which the gaps in the record are exactly what they appear to be: instrument failures, data corruption from proximity to a nuclear detonation, administrative decisions made under time pressure by people who had to choose what to prioritise in the flood of information that poured in from across the Pacific in the days following Starfish Prime. In this version, there is no secret. There is no classified discovery. There is only the normal messiness of a large and complicated program conducted in difficult circumstances by organisations that were not primarily focused on preserving a complete scientific archive for the benefit of future researchers. And there is a version in which the gaps are what the patterns in the missing data suggest they might be: targeted absences, the specific removal of the specific records that would most directly document a specific observation that a specific decision was made not to make part of the public scientific record. In this version, something was found at 230 miles. Something was classified. Something changed the calculus of the people who had the authority to decide what the public and the scientific community would be allowed to know about what the most powerful nuclear explosion in the history of space exploration had revealed about the invisible architecture of the world. Both versions are consistent with the available evidence. The evidence does not distinguish between them with certainty. And in the absence of certainty, the human mind does what the human mind has always done when confronted with incomplete information and a universe that is more complex than it appears. It asks questions. It builds stories. It looks at the patterns in what is missing and wonders what filled the space before the filling was removed. Operation Fishbowl ended. The treaty was signed. The satellites that survived the radiation belt eventually aged out of service and were replaced by newer ones hardened against the kind of electromagnetic insult that Starfish Prime had demonstrated was possible. The artificial radiation belt gradually diminished as the trapped electrons lost energy and scattered, though traces of it persisted for years. The scientists who had been there grew old and mostly did not speak publicly about the things they had seen in the classified portions of the data. The documents were filed, some released, some held, some lost, some simply absent in the ways that raise questions that simple administrative chaos does not fully explain. And the magnetosphere continued its work, as it had done for billions of years before the 9th of July, 1962. As it has done every day since, patient and invisible and essential to every breath taken by every creature on the surface of the planet it surrounds, doing its job with the indifferent competence of a structure that does not require our understanding of it in order to function perfectly. We pressed against it once with the largest hammer we had ever built. We left a mark on it that lasted for years. We signed a treaty within 12 months of the experiment, and we have not, since that night above the Pacific, attempted to find out again what happens when humanity knocks on the invisible ceiling of its world. Perhaps that is wisdom. Perhaps that is fear. Perhaps it is the very particular caution of people who swung hard and felt something swing back and decided, quietly and without public explanation, that the experiment did not need to be repeated. Epilogue: The Invisible Ceiling. Tonight, as you drift towards sleep, the planet is doing what it always does. The magnetosphere is flexing against the solar wind, channeling its energy toward the poles where it cascades down in curtains of light that the people who live beneath them have named the Aurora Borealis and the Aurora Australis. The Van Allen belts are cycling their charged particles around their magnetic highways, maintaining the high radiation environment that keeps the surface below them scrubbed clean of the most energetic particles the sun produces. The plasma pause is holding its boundaries somewhere out in the dark, separating the cold, dense plasma of the inner magnetosphere from the hotter, thinner plasma of the outer regions. And at 250 miles above the Pacific Ocean, approximately where a Thor rocket carried a 1.4 megaton nuclear warhead on the 9th of July 1962, the electromagnetic architecture of the orbital environment continues its silent maintenance work. Whatever structure was there that night, whatever boundary the expanding fireball pressed against and the instruments recorded, and the data archive now partially conceals, is still there. unchanged by the brief violent attention humanity paid it 6 decades ago. Patient in the way that only things which have existed for billions of years can be patient. We live at the bottom of a deep electromagnetic well, surrounded by structures we have only recently developed the tools to measure and the concepts to partially understand. Those structures protect us. They have protected everything that has ever lived on this planet. And for 13 minutes and 41 seconds on a July night in 1962, a group of scientists, engineers and military planners reached up toward those structures with the most powerful tool humanity had ever built. What they found, they did not fully tell us. What the instruments recorded, the complete record does not show. What the treaty that followed suggests, the documents that survive do not confirm. But something happened at 230 miles. Something the fireball met that it did not expect to find. Something that glowed in the dark above the Pacific and left a mark on the orbital environment that persisted for years, and that some of the people who saw it spent the rest of their careers trying to explain away. Maybe they succeeded. Maybe the official explanation is complete, and the gaps in the record are exactly what they appear to be. Instrument failures, administrative inconsistencies, the normal entropy of a large classified program conducted under enormous time pressure in difficult conditions at the height of the most dangerous confrontation in human history. Or maybe, at 230 miles above an atoll in the Central Pacific on the 9th of July 1962, humanity accidentally introduced itself to the wall at the edge of its world, and the wall, in the way that walls do, simply pushed back. Sleep well, the ceiling is holding. There is a kind of silence that does not belong to the natural world. You have heard natural silence, the quiet of a forest at 3 a.m, the breathless pause between thunderclaps, the stillness of snowfall in an empty field. Natural silence has a texture to it. It has biological residue, a distant owl, the creak of a tree branch adjusting to cold air, the whisper of wind moving through grass. Natural silence is never total, because life does not permit totality. Life always inserts itself, always adds its small signatures to the ambient record of a living planet. The silence around our Chuleta Mesa is different. It is the kind of silence that you notice after you've been standing in it for several minutes, the kind that registers not in your ears but somewhere in the older architecture of your nervous system, in the part of you that evolved to identify environments where the normal rules of the world had been suspended. Animals notice this kind of silence before humans do. Dogs stop at certain distances from the mesa and will not proceed. Birds alter their flight paths. The cattle that used to graze in the lower pastures north of Dulce showed a behavioural avoidance of specific areas near the mesa's base that the ranchers who watched them noticed and remarked upon to anyone who would listen, long before anyone was paying close attention to what the cattle themselves were being subjected to. The town of Dulce, New Mexico, sits at an elevation of roughly 6,900 feet on the Colorado Plateau, nestled against the southern slopes of the Jicarilla Mountains within the boundaries of the Jicarilla Apache Nation. The population has hovered around 2,000 for most of the past half-century, the kind of number that produces a community small enough to be intimate and large enough to have witnessed things collectively, to have generated a shared memory of events that the wider world was never told about. The main road through town is paved. The surrounding roads diminish quickly from paved to gravel to dirt to track, to something that is only navigable by someone who already knows where they're going. The mesa rises to the north of town like a geological sovereign, broad-shouldered and permanent, its layered sandstone face reading the accumulated history of 200 million years of planetary time, with an indifference to human presence that feels, if you spend enough time looking at it, almost deliberate. This is the place where the story begins. Not because stories need a place. Stories need only people and events, and the willingness to follow truth wherever it leads, even when it leads somewhere that every institutional voice in the room is instructing you not to go. But this particular story is inseparable from this particular geography, from the specific combination of remoteness and geology, and federal land status and historical accident that made this mesa, this town, this stretch of high desert in northern New Mexico the location that someone, or something, chose for purposes that 50 years of investigation have not fully illuminated, and that official silence has consistently and deliberately refused to examine. What happened in Dulce, or what the evidence suggests happened, or what the people who were there and the people who came after them, and the people who died before they could finish telling what they knew, all agree, in their separate and uncollaborated ways, happened, is one of the most extensively documented and deliberately suppressed stories in the modern history of the American Southwest. It involves cattle and blood and precision cuts made by instruments that leave no trace of their origin. It involves nuclear detonations and geological surveys and the creative bureaucratic architecture of programs that do not appear in any public budget. It involves a man who built underground structures for the United States government and who spent the final year of his life telling anyone who would listen exactly what he had found in the dark, and who was dead at 44 under circumstances that a rubber catheter and a missing medications bottle and a ransacked filing cabinet made very difficult to accept as self-inflicted. It involves the question of what is beneath the mesa, and it involves the growing, deepening, increasingly difficult to dismiss suspicion that whatever is beneath the mesa is not only still there, but has never stopped operating. The story does not start with conspiracy, it starts with livestock. The summer of 1975 arrived in the high desert of northern New Mexico the way it always does, with a shift in the quality of light that happens almost overnight, a deepening and intensifying of the gold and amber tones in the landscape that announces the shift from the cool clarity of spring into the particular fullness of high-altitude summer. The ranchers of the Dulce area had been working their land for generations in some cases. They knew the rhythms of the desert the way you only know something when your livelihood depends on reading it correctly. They knew what a healthy herd looked like. They knew the way cattle behaved when they were stressed. They knew, without having to think about it, every predator that shared their range, coyote, mountain lion, bear, and they knew precisely what each predator did to the animals it killed. None of them had ever seen anything like what they began finding in the summer of 1975, and what continued to appear with a regularity that transformed initial shock into a sustained, grinding dread through 1976 and beyond. The animals were dead. That part was conventional enough. Cattle die. They die from illness, from predator attacks, from exposure, from any number of causes that a rancher factors into the annual arithmetic of a working operation. But the manner of death in these cases was not any cause that any rancher in the area had ever encountered. The animals showed no signs of distress prior to death. No running, no defensive injury, no evidence that they had been chased or attacked in any way that left the kinds of physical evidence that a pursuit and kill event invariably produces. They simply appeared, in the morning hours when ranchers made their checks, in the places where the night had left them with specific parts removed, not torn, not chewed, not broken, removed, with a precision that transformed the carcass from the site of an animal's death into something that resembled the result of a surgical procedure conducted under controlled conditions by someone with both an extensive knowledge of bovine anatomy and access to instruments capable of making incisions that left edges so clean, so perfectly bounded, so entirely free of the ragged tissue trauma that any conventional cutting instrument produces, that the veterinary professionals who examined them were, in some cases, visibly unsettled. An ear, removed from the base of the skull with a single continuous cut that followed the exact boundary of the auricular cartilage. The tongue, extracted from the oral cavity through an opening that had been made in the underside of the jaw, reaching to a depth that would have required either very long instruments or the disassembly of the jaw structure, neither of which had occurred. The jaw was intact, the opening was small and precise, and the tongue was simply gone, removed as cleanly as if it had been placed on a surgical tray. The eyes, in most cases. The genitals, in virtually all cases. In some animals, organs that would have required incisions through the body wall, the stomach, the heart, sections of intestine, had been removed through openings that did not tear the surrounding muscle or disturb the adjacent tissue in any way that was consistent with manual extraction. In cases where laboratory analysis was possible, the cut edges showed evidence of heat treatment, a cauterization effect that sealed the wound even as it was made, as though the instrument that created the opening was simultaneously cutting and closing, operating at a speed or with a technology that prevented the bleeding that any cut to living tissue or recently living tissue invariably produces. And then there was the blood, the absence specifically of blood, not reduced blood, not blood that had pooled and drained away, no blood. On the animal, at the site of the wounds, on the ground for a radius that investigators searched carefully and repeatedly. A 2-year-old heifer contains approximately 12 gallons of blood. Every one of those gallons was missing from the scene, missing not in the sense that it had drained into the soil. Ground soaks blood in ways that leave evidence, discoloration, thickening, changes in the surrounding vegetation and insect activity, but missing in the sense that it had been removed, taken, as neatly and completely as the organs. Gabe Valdez was the man who had to figure out what to make of all this. He was a New Mexico State police officer assigned to the Dulce area, a practical man in a practical job in a practical part of the world, where the most common call was a traffic incident or a domestic dispute or a boundary conflict between ranchers, the ordinary inventory of rural law enforcement. When the first mutilation reports came to his desk in the summer of 1975, he treated them as he treated everything, as problems to be worked through methodically, with evidence at the centre and speculation at the margins. He drove out to the ranches. He photographed the carcasses in detail, building a visual record that would eventually run to hundreds of images. He collected tissue samples and sent them to veterinary laboratories at the state university. He documented the perimeter of each site, looking for tracks, for physical evidence of how the animals had been approached, for anything that might indicate the method of death and the method of tissue removal. He interviewed every rancher who made a report, and then he interviewed their neighbours, and then he interviewed the neighbours' neighbours, building the widest possible net of information around the events. What came back from the laboratories confirmed what the ranchers had already known from visual inspection. The cuts were not made by animal teeth or claws or any conventional blade. The precision was extraordinary. The heat treatment at the wound edges was real and measurable. The absence of blood was not an artifact of how the samples had been collected or processed. It was a genuine characteristic of the carcasses. And the insect activity, which forensic entomologists would use in subsequent analyses of similar events across the American West, was anomalous in a specific and meaningful way. Flies and beetles that would ordinarily colonize a fresh carcass within hours were, at these sites, absent or dramatically reduced in number, as though something about the condition of the animals was rendering them unattractive as a substrate for insect activity, which required some property of the tissue that no conventional explanation adequately accounted for. The tracks that Valdez found near several of the carcasses have remained among the most discussed physical evidence in the entire Dulce file. They were not animal tracks. They were not human footprints. They were impressions in the soil that had a regularity of spacing and a consistency of depth and a geometry that Valdez, who had worked enough crime scenes to be able to read physical evidence with practiced eyes, could not reconcile with anything biological. The impressions were approximately circular, roughly 8 to 10 inches in diameter, sunk to a uniform depth of about an inch regardless of the varying softness of the surrounding soil, and spaced with a mechanical consistency, the same distance apart in the same geometric relationship site after site, not the variable pressure-dependent spacing of an animal gait, not the organic irregularity of human footsteps on uneven terrain, something else. Something that moved with a uniformity of applied force and spatial distribution that suggested not legs but landing pads, not walking but touching down and lifting off, repeatedly, with the precision of a mechanism rather than the variability of a biological limb. Then there were the objects. In the case files that Valdez maintained with a thoroughness that exceeded what his posting required of him, He was not under any institutional pressure to pursue these investigations as deeply as he did. The pressure he felt was internal, the pressure of a person who has looked at something he does not understand and cannot let it go. There are references to physical artifacts found near some of the mutilation sites. He described them as mask-like in shape, fabricated from a material he could not identify, and bearing no markings or features that gave any indication of their origin or purpose. These objects disappeared from the evidence record before they could be subjected to the kind of laboratory analysis that might have produced meaningful data. The chain of custody, in at least 2 cases, simply ends. The objects were logged, transferred to a law enforcement facility for storage, and then, when subsequent requests were made for them, were reported as either missing or never having arrived. This kind of evidence disappearance, which researchers would document repeatedly across multiple categories of physical evidence connected to the Dulce investigation, does not happen by accident. Physical evidence logged and transferred through official channels does not simply cease to exist unless someone with the authority and the motive to remove it has done so. The helicopters were perhaps the element that Valdez found most disturbing in his years of investigation, because unlike the wound patterns and the missing blood and the enigmatic tracks, helicopters were human technology, and their persistent appearance in the windows of time surrounding the mutilation events implied a human role in whatever was occurring. They were not commercial aircraft. They were not the agricultural spraying operations that occasionally work the area. They were unmarked, dark-coloured rotary wing aircraft that flew at night without lights, at altitudes that kept them below standard radar coverage, along routes that Valdez began to map after tracking enough sightings from enough witnesses over enough months to start seeing the patterns in their behaviour. The patterns were not random. The flight corridors, when plotted on a map of the region, converged on a specific area, the land around and above Archuleta Mesa. Not every flight. Not in a way that was so obvious a casual observer would have noticed it, without the accumulated mapping that Valdez had done, but with a statistical consistency that, when Valdez looked at his maps in the evenings after his official duties were done, made the back of his neck prickle in a way that had nothing to do with the cold. The helicopters came from the mesa, or they went to the mesa, or they orbited the mesa in patterns that suggested observation rather than transit, and they appeared again and again in the nights immediately before or after mornings, when ranchers would find that the surgery had been conducted on another of their animals. Valdez reported all of this. He reported it to his superiors at the New Mexico State Police. He reported it to the FBI office that eventually, under congressional pressure in the late 1970s, opened a nominal investigation into the cattle mutilation phenomenon. He reported it to researchers and journalists who came to Dulce because the story had begun to seep into the wider cultural conversation through the kinds of channels that official suppression cannot fully close: local newspapers, regional radio, the word-of-mouth networks of rural communities who tell each other what is happening, because they do not have the luxury of institutional authority to tell them it is not important. The FBI's investigation, conducted between 1979 and 1980 under the direction of Special Agent Ken Rommel, produced a report of some length and essentially no substance. The report attributed the mutilations to natural predator activity in carrion scavengers, and to what it characterized as the overwrought imaginations of ranchers unfamiliar with the normal processes of animal decomposition. Gabe Valdez, who by the time the report was released had documented hundreds of incidents and accumulated a body of physical and testimonial evidence that would have been considered significant in any honest investigative context, received this conclusion with a degree of contained fury that those who knew him described as one of the more restrained reactions a man could have to being told, in official language, that everything he had carefully documented had not actually happened. He continued investigating on his own time. He continued until the end of his life. He died in 2010, still asking questions that no official body had ever genuinely tried to answer. To understand why Gabe Valdez's questions were never answered, you have to understand the geography of secrecy that surrounded the place where he was asking them. Northern New Mexico in the 1970s was not simply a remote stretch of high desert. It was the deep operational hinterland of the most extensive complex of classified defense and nuclear research facilities in the world. Within a radius of roughly 150 miles from Dulce, you had Los Alamos National Laboratory, which had been the birthplace of the atomic bomb and remained the most significant nuclear weapons research facility in the United States. You had Sandia National Laboratories, which handled the engineering and systems integration of the nuclear weapons program. You had Kirtland Air Force Base, which maintained nuclear weapons storage and served as a hub for classified aerospace programs. You had White Sands Missile Range, where generations of American weapon systems had been tested in the isolation of the Chihuahuan Desert. You had Holloman Air Force Base. You had a web of smaller facilities and monitoring stations and research outposts that existed in the classified bureaucratic ecosystem that surrounded the public institutions like the unseen portion of an iceberg. This geography of secrecy had specific practical consequences for anyone attempting to investigate unusual phenomena in the region. The classification infrastructure of the national laboratories extended well beyond their physical boundaries. Personnel who worked at Los Alamos lived in the surrounding communities and were bound by security agreements that, in some cases, covered not just their work but their observations and communications more broadly. The culture of institutional silence that the nuclear program had cultivated over decades, a culture in which not asking about things you were not authorized to know was as important as not telling things you were authorized to know, permeated the social fabric of northern New Mexico in ways that were subtle and pervasive and largely invisible to anyone who had not grown up inside it. When strange things happened in this environment, the default response of the people most likely to have relevant knowledge was not to tell. It was to say nothing, and to maintain that nothing with the practiced ease of people, for whom institutional silence was not an unusual burden, but a lifetime habit. Into this environment, something had been added in December of 1967 that the public record acknowledges and the conspiracy framework interprets in a way that is either paranoid or incisive, depending on your starting assumptions. Project Gas Buggy was real. Every element of its official description is documentable. It was part of the Plowshare Program, a genuine initiative of the United States Atomic Energy Commission that ran from 1958 to 1973 with the stated goal of finding industrial applications for nuclear explosives. The program detonated 27 nuclear devices in total in locations across the American West, for purposes that range from the ambitious to the absurd: harbour excavation in Alaska, canal construction in Panama, natural gas stimulation in Colorado and New Mexico. Project Gas Buggy was the natural gas stimulation experiment conducted in partnership with the El Paso Natural Gas Company at a site in the Carson National Forest in Rio Arriba County, New Mexico, approximately 30 miles southwest of Dulce. On December 10th, 1967, at 10 o'clock in the morning, a 29-kiloton nuclear device was detonated at a depth of 4,240 feet below the surface. The explosion fractured the surrounding rock formation, releasing natural gas trapped within it. The gas, when subsequently tested, was found to contain tritium and other radioactive isotopes at levels that made commercial use impractical. The project was evaluated as a partial technical success and an economic failure. The Plowshare Program continued for a few more years with other experiments before being terminated in the early 1970s. That is what the public record says. Now consider what the public record does not say, and what the geography and geology of the region make it reasonable to ask. A 29-kiloton nuclear detonation at 4,000 feet creates a pressure wave that travels outward through the surrounding rock in every direction simultaneously. The characteristics of that pressure wave as it moves, its amplitude, its frequency, its interaction with the specific formations it encounters, are functions of the geological structure through which it is propagating. In a region as geologically complex as northern New Mexico, with its ancient volcanic intrusions and its extensive limestone formations, and its well-documented networks of natural cave systems and subsurface voids, The propagation of that pressure wave is not a simple radiating sphere of uniform energy. It is a complex three-dimensional interaction between the wave and the geological structure, and it produces, in the rock through which it passes, a record of that structure, a seismic tomography in effect of everything between the blast point and wherever the wave's energy finally dissipates. The Atomic Energy Commission would have known this. The geophysicists working on Project Gasbuggy would have known this. The seismic monitoring equipment deployed around the blast site to study the explosion's effects would have recorded in considerable detail exactly how the pressure wave interacted with the surrounding geology, which means it would have produced, as a byproduct of the natural gas stimulation experiment, an extremely detailed map of the subsurface geological structure of a region that included the area beneath Archuleta Mesa. Some of this seismic data is publicly available, some of it remains classified. The classification of seismic data from a natural gas stimulation experiment conducted in 1967 has never been explained in terms that connect to any specific national security concern related to natural gas. The explanation most commonly offered, when any explanation is offered at all, is that the data contains information about nuclear device design that could be exploited by foreign powers, a rationale that has been used to justify the classification of an enormous variety of Plowshare program data, and that may in some cases be genuine, and in others may be the bureaucratic equivalent of a closed door with a sign on it that says nothing to see here. The conspiracy interpretation does not require that Project Gasbuggy was secretly intended to excavate an underground base. That would be a reach beyond what the evidence supports. What it requires is something more modest and more plausible, that the geological survey data generated by Project Gasbuggy gave certain people within the classified defense establishment a detailed and actionable picture of the subsurface terrain beneath Archuleta Mesa, and that this picture informed decisions that were made in the subsequent decade about what could be built beneath that mesa, and how and to what depth, and with what connection to the natural geological features already present. The natural features already present were extensive. The Archuleta Mesa sits atop a geological formation that geologists have long recognized as containing significant natural cave systems. The limestone and sandstone strata of the Colorado Plateau in this region are riddled with solution caves, fracture caves, and collapse features that create natural underground spaces of widely varying sizes. Some of these spaces are known and mapped. Some have been entered by cavers and documented in the speleological record. Some almost certainly remain undetected by any systematic survey, existing in darkness and silence at depths where the weight of the rock above them is the only witness to their presence. Natural cave systems of the right scale, in the right geological context with the right access points, represent a significant engineering advantage to anyone planning an underground installation. You do not need to remove all the rock yourself. You need to identify what the rock has already removed for you over millions of years of geological time, and then connect those spaces, reinforce them where necessary, and build within the framework that nature has already provided. The construction footprint is smaller. The excavated material that needs to be disposed of is less. The acoustic and seismic signature of the construction is reduced, and the resulting facility is more naturally adapted to the underground environment than anything built entirely from scratch, because it sits within a structure that has already proven its stability over timescales that no human construction project can match. If the seismic data from Project Gasbuggy showed what the conspiracy framework suggests it showed, the Eye of Atlantis, secrets beneath the Sahara, before we begin, I want to thank Alwyn, eventually, for suggesting this incredible topic. Your curiosity drives us to explore the mysteries that history has buried, and today's story is one that will challenge everything you thought you knew about human civilization. Imagine standing at the edge of infinity. The sun beats down on endless dunes that stretch to every horizon, waves of sand frozen in time. You're in one of the most remote places on Earth, the Western Sahara of Mauritania, where few humans venture and even fewer return unchanged. But you're not here for the desert. You're here for something that should not exist. Something so massive, so perfectly formed, that it can only truly be seen from space itself. From orbit, astronauts have called it the most remarkable feature in Africa. Geologists call it an anomaly. Ancient theorists call it proof. The locals who live in its shadow call it cursed. But to those who dare to connect the dots between myth and reality, it has another name entirely. They call it Atlantis. This is the story of the Rishi structure, a formation so immense and so geometrically precise that it defies every explanation we have been given. This is the story of how a philosopher's legend became an archaeological obsession, how satellite imagery revealed what ground expeditions could not find, and how the greatest mystery of the ancient world might be hiding not beneath the waves of the Atlantic Ocean, but beneath an ocean of sand. What you're about to hear will make you question the timeline of human history. It will make you wonder what else has been buried, redacted, or simply forgotten. Because in the heart of the Sahara lies a perfect circle, and within that circle may lie the answer to humanity's oldest question. Where did we really come from? The discovery. The year was 1965. Astronaut James McDivitt was aboard Gemini 4, orbiting Earth at speeds that would make the mind reel. He was supposed to be focused on his mission parameters, on the technical readings and trajectory calculations that kept him alive in the vacuum of space. But something caught his eye through the small window of his capsule, something down on the surface of northwest Africa that made him reach for the camera. What he photographed that day would haunt researchers for generations. It appeared as a perfect bullseye in the desert, concentric circles of rock radiating outward from a central point with mathematical precision. The formation was enormous, stretching approximately 25 miles across, visible only because of the altitude and angle of his spacecraft. From the ground it would be impossible to see. From orbit it was unmistakable. The photograph was filed with thousands of others from the Gemini program, labelled and archived. But it kept appearing in subsequent missions. Apollo astronauts saw it. Shuttle crews saw it. Every single orbital mission that passed over Mauritania captured the same haunting image. A perfect eye staring up from the Sahara. The scientific community took notice. In the early 1970s, the Geological Survey of Mauritania conducted the first detailed mapping expedition to the site. What they found both explained and deepened the mystery. The formation consisted of 3 distinct concentric rings, each composed of different rock types. The outer ring was limestone, ancient and weathered. The middle ring was quartzite, harder and more resistant to erosion. The inner ring contained rhyolite, a volcanic rock that suggested deep geological forces at work. They named it the Risha structure, after the small desert town of Wudan that sat near its perimeter. The official explanation was presented with confidence. This was an eroded geological dome, created by the uplift of rock layers over hundreds of millions of years, then slowly worn down by wind and rare desert rains into this circular pattern. Case closed, they said. Natural formation. Nothing more to see. But there was a problem with that explanation. A problem that would not go away no matter how many times the scientific establishment repeated their conclusions. The symmetry was too perfect. The spacing between rings was too regular. The ratios were too precise. Natural erosion is chaotic, random, asymmetrical. Rivers carve irregular paths. Wind creates jagged formations. Time does not draw with a compass. Yet here, in the middle of nowhere, was a structure that looked exactly as if someone had used a compass the size of a mountain range to draw 3 perfect circles in the earth itself. The measurements were even more troubling. When surveyed with precision instruments, the rings showed spacing ratios that appeared intentional. The distances between them followed patterns that seemed almost mathematical, and the entire structure was oriented with geographic precision that natural forces do not typically produce. Geologists publish papers explaining the dome theory. They showed diagrams of how uplifted rock could erode into circular patterns under specific conditions. They pointed to other geological domes around the world as comparison. But none of those other formations looked anything like the Richat structure. None had the perfect symmetry. None had the precise spacing. None looked like they had been designed. And then someone remembered Plato. Plato's blueprint. In 360 BCE, the Greek philosopher Plato wrote 2 dialogues that would become the most famous unsolved mystery in human history. In Timaeus and Critias, he described a legendary island civilization called Atlantis, a place of advanced technology and culture that was destroyed in a single day and night of catastrophic floods. For over 2,000 years, explorers and historians searched for Atlantis. They looked in the Mediterranean Sea, in the Atlantic Ocean beyond the Pillars of Hercules, in the Caribbean, in Antarctica, in dozens of locations around the globe. Every generation had a new theory, a new location, a new explanation for where this legendary civilization might have existed. But every theory had the same problem. None of them matched Plato's actual description, because Plato had not been vague. He had been remarkably specific. He described Atlantis as a circular island consisting of concentric rings of land and water. He gave precise measurements for these rings. He described mountains to the north and open plains to the south. He mentioned that the civilization had access to a rare red, black and white stone. He explained that the city was positioned near a coastal plain that opened to the sea. Historians had always assumed these details were fictional embellishments, the kind of creative additions that storytellers make to give their tales authenticity. After all, Plato was writing about events that supposedly occurred over 9,000 years before his time. How could he possibly know such specific details? But in the late 1990s and early 2000s, independent researchers began comparing Plato's descriptions to the Richat structure. And what they found was extraordinary. Plato had described the outer ring of Atlantis as being approximately 127 stadia in diameter. A stadia was an ancient Greek unit of measurement roughly equivalent to 185 meters. When you convert Plato's measurements to modern units, the outer ring of Atlantis should be approximately 23.5 kilometers across. The outer ring of the Orisha structure measures approximately 23 kilometers in diameter. Plato described the spacing between the rings in specific ratios. The second ring was supposed to be smaller by a precise proportion, and the inner ring smaller still. When researchers measured the Richat structure, the ratios matched within margins that seemed impossible to attribute to coincidence. Plato mentioned that Atlantis had mountains to the north. The Richat structure sits at the base of a highland region to its north. Plato said the civilization faced south toward the sea. In ancient times, before the Sahara became desert, a vast network of rivers and lakes extended south from the Richat region toward what would have been a much larger ancient shoreline. Plato described 3 types of stone used in Atlantean construction: red, black, and white. The Richat structure contains red rhyolite, black volcanic breccia, and white limestone, all present in the geological layers of the site. One by one, the correspondences stacked up. Every detail that Plato had provided matched the Richat structure in ways that no other proposed location for Atlantis had ever matched. It was as if Plato had been describing this exact place, this exact formation, with a precision that should have been impossible for someone writing 2,000 years before satellite photography. The implications were staggering. If Plato had been accurate about the physical description, could he have been accurate about the rest? Could there truly have been an advanced civilization at the Richat structure, a civilization that existed before the desert consumed it? To answer that question, researchers had to answer another one first. Could the Sahara have ever supported such a civilization at all? The Green Sahara. When you picture the Sahara Desert today, you imagine the largest hot desert on Earth, a realm of endless dunes and scorching heat where nothing can survive. But the Sahara has not always been a desert. and the proof of that lies written in the rocks, the fossils, and the satellite images that reveal what the sand has tried to hide. Between approximately 12,000 and 5,000 years ago, the Sahara was green. Climate scientists call this period the African Humid Period, a time when the Earth's axial tilt and orbital patterns created different weather systems across North Africa. Instead of the bone-dry wasteland we know today, the region was filled with rivers, lakes, forests, and grasslands. Satellite studies conducted by NASA and the University of Arizona using synthetic aperture radar have revealed vast networks of ancient riverbeds beneath the sand. These were not small streams, but major river systems comparable to the Nile, flowing from the interior highlands toward ancient lake basins. One of these river networks passed directly through the region where the Risha structure sits. The fossil record confirms what the radar images suggest. Archaeologists and paleontologists have discovered bones of crocodiles, elephants, hippos and giraffes scattered throughout the Sahara, including in areas very close to the Riche structure. These are not desert animals. They're creatures that require abundant water and vegetation. Their presence proves that the Sahara once sustained rich ecosystems. Rock art found in caves throughout Mauritania and the broader Sahara shows ancient peoples hunting and herding in landscapes filled with wildlife and water. These paintings, some dating back over 10,000 years, depict scenes that would be unimaginable in the current desert. Cattle grazing, people swimming, lush vegetation everywhere. Local Berber and Tuareg oral traditions contain stories passed down through countless generations about cities that once existed in regions now covered by sand. They speak of a time when their ancestors lived in places of great abundance, before the rains failed and the desert consumed everything. They describe ruins beneath the dunes, places where the sand sometimes shifts to reveal ancient walls and forgotten structures. For decades, Western academics dismissed these stories as mythology, the kind of exaggerated tales that every culture tells about a golden age in the distant past. But as satellite technology improved and as archaeological evidence accumulated, researchers began to realize these oral traditions might contain fragments of actual historical memory. If the Sahara was green and fertile during the African humid period, if it supported complex ecosystems and human populations, then a major civilization could have existed there, and if such a civilization had been centered at the Risha structure during that verdant age, it would have had access to everything it needed: water from rivers and lakes, stone from the geological formation itself, a commanding view of the surrounding landscape, and a location that would have been near ancient coastlines or major waterways. But then something happened. Around 5,000 years ago, the climate shifted. The rain stopped. The rivers dried up. The lakes evaporated. The green Sahara died, and the desert we know today was born. Any civilization that had existed in the interior Sahara would have faced a catastrophic collapse. Not from floods washing their cities into the sea, as Plato had described, but from the opposite, from water disappearing entirely, from fertile lands becoming barren, from the life-giving rivers turning to dust. Could Plato's story of Atlantis being destroyed by water have been a garbled version of the truth? Could the ancient tale have been about a civilization that died not because water came, but because water left? Could the flood that destroyed Atlantis have been a flood of sand instead? The evidence beneath the surface. When you look at satellite imagery of the Riche structure with fresh eyes, with the possibility that it might be more than just geology, patterns begin to emerge that the official explanations cannot quite account for. The circular ridges that form the famous rings are not uniform in their erosion. In several places they show what appear to be breaches or gaps at regular intervals, as if something other than random weathering created passages through them. These gaps align with what would be expected if the rings had once been reinforced walls with deliberate entry points. Radial patterns extend outward from the inner rings like spokes on a wheel. Erosion alone rarely creates such geometric regularity. But if the ancient inhabitants had built causeways or roads radiating from a central administrative area outward to the peripheral zones, this is exactly the pattern we might expect to find after thousands of years of degradation. The most intriguing evidence comes from analysis of the rock itself. Samples taken from the outer ring areas contain traces of petrified marine organisms, shells and fossilised remnants of sea life that confirm this region was once under or adjacent to water. While this supports the Green Sahara theory, it also raises questions about what else might be preserved in those stone layers. Independent exploration teams who have visited the site report finding tool fragments and stone artefacts in the wadis and depressions around the structure. Some of these artefacts have been carbon dated to over 10,000 years ago, placing them squarely within the time frame when Atlantis was supposed to have existed according to Plato's chronology. Critics immediately point out that finding ancient stone tools in the Sahara is not unusual. Humans have lived in North Africa for hundreds of thousands of years, and stone tools are common throughout the region. These artefacts, they argue, have nothing to do with the Risha structure specifically, and certainly do not prove the existence of an advanced civilization. But proponents counter that the consistency and concentration of findings around the Risha area suggest something more than random hunter-gatherer presence. They point to the types of tools discovered, some of which show sophisticated manufacturing techniques. They note the presence of what appear to be worked stones too large to be simple tools, blocks that might have been part of construction projects. The debate intensifies when discussing what lies beneath the surface. Ground-penetrating radar studies conducted by independent researchers have detected unusual subsurface anomalies within the Rishat structure. Dense strata with geometric patterns, possible void spaces that could indicate chambers or tunnels, symmetrical underground formations that do not fit standard geological models. These findings have not been peer-reviewed or officially published, which mainstream scientists cite as proof of their unreliability. But the researchers who conducted these studies claim they have been unable to get their work published, precisely because it challenges accepted theories. They describe a pattern of journals rejecting their papers without proper review, of academic conferences declining their presentations, of institutional barriers that prevent serious examination of non-mainstream theories about the site. Every piece of evidence that might support the Atlantis theory is met with skepticism and alternative explanations. Every anomaly is dismissed as misinterpretation or equipment error. Every correspondence between the Rishat structure and Plato's description is labelled coincidence. And yet the evidence keeps accumulating. The patterns keep appearing. The questions keep demanding answers that the official explanations cannot quite provide. Which brings us to perhaps the most damning evidence of all, the evidence that someone does not want this site investigated too closely. The Wall of Silence. If the Riche structure is just an eroded geological dome with no archaeological significance, then researching it should be straightforward. Submit a proposal, get a permit, conduct excavations, publish findings. This is how archaeology works at sites around the world. But the Rishat structure is different. Multiple research teams have applied for permits to conduct archaeological excavations within the formation. They have submitted detailed proposals outlining non-invasive survey methods, careful excavation protocols, and collaborative frameworks with local authorities. These applications have been denied repeatedly by Mauritanian government officials, often without clear explanation. The official reasons given vary. Sometimes the authorities cite heritage protection concerns, arguing that the site must be preserved from potential damage. Sometimes they mention environmental sensitivity, claiming that research activity might disrupt the desert ecosystem. Sometimes they simply say the area is closed to archaeological investigation, without providing any justification at all. UNESCO has listed the Risha structure in its World Heritage Tentative List, acknowledging the site's potential significance, but this listing has not led to increased access for researchers. Instead, the area remains classified as environmentally sensitive with strict limitations on who can work there and what methods they can employ. researchers who have tried to work in the region describe a pattern of obstruction. Local officials who initially express interest in supporting expeditions suddenly become unreachable. Equipment shipments get held up in customs indefinitely. Required permissions get delayed month after month until research seasons pass and funding windows close. It is never an outright refusal, just an endless series of bureaucratic tangles that make serious investigation effectively impossible. Some Western academics who have expressed interest in Saharan archaeology related to the Risha structure report similar obstacles from their own institutions. Grant proposals get rejected with vague criticisms about methodological concerns. Department heads discourage junior researchers from pursuing these topics, warning that it could harm their careers. Peer reviewers block papers from publication, not because of flawed data, but because of controversial implications. One researcher, speaking anonymously to avoid professional repercussions, described the situation bluntly. When your findings challenge established timelines of civilization, the work simply stops receiving support. They do not say you are wrong. They do not engage with your evidence. They just make it impossible for you to continue. The phrase they use is methodological inconsistency, but everyone knows what it really means. Stop digging. This pattern of obstruction extends even to remote sensing data. Several researchers report that high-resolution satellite imagery they had been using for analysis suddenly became restricted or degraded in quality. Digital elevation maps that showed detailed topography of the Risha structure mysteriously disappeared from open archives. Ground-penetrating radar data that had been collected vanished from institutional databases. When questioned about these missing data sets, authorities offer technical explanations, routine data management, updated privacy protocols, licensing restrictions. But the consistency of the pattern is hard to ignore. Data that might support non-mainstream theories about the site becomes unavailable, while data that supports conventional geological explanations remains readily accessible. The silence extends to the media as well. Major documentaries about ancient mysteries and lost civilizations routinely cover the Atlantis legend, but they rarely spend significant time on the Risha structure despite its remarkable correspondences with Plato's description. When it is mentioned, it is usually dismissed quickly with the standard geological explanation, before moving on to more sensational but less evidentially supported locations. Why would so many institutional barriers exist around a site that is supposedly just an eroded rock formation? If there is nothing there, why prevent serious investigation? If the geological explanation is correct, why not allow research that would conclusively prove it and put the Atlantis theories to rest? The refusal to allow thorough investigation becomes its own form of evidence. The silence screams louder than any artifact could. The global pattern. The story of the Risha structure does not exist in isolation. Around the world, researchers have identified other sites with striking similarities, massive stone constructions of uncertain age, precisely aligned with astronomical or geographic markers, built with techniques that seem impossibly advanced for their supposed time periods. On the Mediterranean island of Malta, prehistoric temples display architectural sophistication that mainstream archaeology struggles to explain. These structures feature precisely cut megalithic blocks, some weighing over 50 tons, fitted together with remarkable precision. Carbon dating places some of these temples over 5,000 years old, making them older than the Egyptian pyramids and contemporary with the Green Sahara period. In Bolivia, the site of Pumapunku contains stone blocks with perfectly smooth surfaces and complex geometric cuts that would challenge modern manufacturing. The blocks show evidence of advanced stoneworking techniques, possibly even machine precision. The ruins include megalithic platforms and structures arranged in geometric patterns. Mainstream dating places the site at around 1,500 years old, but some researchers argue the stonework could be much more ancient, citing evidence of weathering patterns and astronomical alignments. In the Azores, Underwater formations off the coast have been identified by some researchers as possibly artificial structures, though this remains highly controversial. Sonar imaging has revealed what appear to be rectangular formations and straight-edge alignments on the sea floor, in patterns that are difficult to attribute to natural geological processes. Advocates of alternative history theories connect these sites through a proposed framework. An ancient maritime civilization that existed during the late Ice Age and early post-glacial period, before conventional timelines placed the rise of complex societies. This civilization, they argue, was centered in regions that are now underwater or desert, regions that were habitable and even thriving during the different climate conditions of that era. The Younger Dryas event provides a potential mechanism for this civilization's destruction. Between approximately 12,800 and 11,600 years ago, Earth experienced a rapid cooling period that disrupted ecosystems worldwide. Sea levels rose as ice sheets melted and reformed in complex patterns. Coastlines changed dramatically. What had been fertile lowlands became ocean floor. What had been verdant landscapes became frozen